students, in last session we have discussed about definition of vectors and different types of vectors. In that we have seen zero vector, unit vector, collinear, coinitial, and different types of vectors we have discussed. In today's session we'll see what is negative of a vector, and then we'll go for algebra of vectors. In algebra of vector we are going to discuss scalar multiplication, addition and subtraction of two vectors. So let us see first point, which is negative of a vector. Negative of a vector. If a vector E is given to you, suppose vector A is given to you, then its negative vector is denoted by minus of vector A, and it is a vector having same magnitude but having opposite direction. So suppose this is vector A given to you, then minus of vector A will be a vector of same magnitude, length will be the same, but direction is exactly opposite. So this is said to be negative of vector. So you can see that magnitude of A and magnitude of minus vector A, this is same. Then what is different thing? Difference is in their direction. Direction is exactly opposite. This is vector AB having direction from A to B. Then negative of vector AB will be vector BA. It is same vector having same length, but direction will be exactly opposite. So this will be vector BA. So you can write vector AB, this is equal to minus of vector BA. Okay, so their terminal and initial points are exchanged. Initial point of vector A is the terminal point of vector BA. Initial terminal point of vector B is the initial point of vector BA. So exchange of initial and terminal point is there. So you can write vector AB is equal to minus vector BA. So minus vector BA can be written as vector AB. Okay. So this is negative of a vector. Here also you can write magnitude of vector AB is same as magnitude of vector BA. Their magnitude is same, but why minus sign is given? Because their direction is exactly opposite. यहाँ पे हमने AB is equal to BA क्यों नहीं लिखा? Magnitude of AB is equal to magnitude of BA, but direction is opposite. So we write vector AB is equal to minus of vector BA. So this is about negative of a vector. Now next point we are going to discuss is algebra of vector. Algebra of vectors. Vectors in detail we have defined, discussed. So now we'll see how to add two vectors, how to subtract two vectors, how to multiply a vector by a scalar. So in algebra of vector, we'll first see what is scalar multiplication. Scalar multiplication means multiplying a vector by a scalar. So suppose a vector A is given to you and K is any scalar. Scalar means it is not having direction and you can consider it as any real number. So vector A is vector and K, this is vector and this is a scalar. Then scalar multiple of vector A is K vector A, and it is defined as K vector A is a vector whose magnitude is K times as that of magnitude of A, whose direction is same as that of magnitude of A if K is positive. If K is negative, K greater than 0 means K is positive. If K is negative, then K vector A will have opposite direction as that of vector A. See, this is my vector A, given vector. It will have some magnitude and it is having one direction. When I multiply it by a scalar K, I will get a vector parallel to the given vector, and if this k is positive, it will be in the direction of given vector. Suppose length of vector A is 5 and suppose k, value of k is 2. So what you get? You get a vector in same direction as that of vector A, but its length will be 10, that is 2 times magnitude of vector A. As k is positive, its direction will be the same. But if I multiply it by -2, okay, that is a value of k, suppose it is less than 0, negative. Again you will get a vector of magnitude 10 unit, but now its direction will be exactly opposite to that of direction of vector A. So if k is negative, k vector A will be in opposite direction. If k is positive, k vector A will be in the same direction. In both cases, magnitude will be the k times magnitude of vector A. Magnitude of k vector A is k times magnitude of vector A. I am writing k in mod because it may be positive or negative, but while writing magnitude it must be positive, so that's why I am writing k in a mod. We are taking its absolute value. So magnitude of k vector A is mod of k into magnitude of vector A. So magnitude of k vector A is k times magnitude of vector A, and direction depends upon the sign of scalar k. If it is positive, it is in same direction. If it is negative, it is in opposite direction. Now what if k is equal to 0? If k is equal to 0, you get a 0 vector. Okay, 0 is a scalar, and when you multiply a vector by a 0, you will get a 0 vector. Now here always remember that when we multiply a vector by a scalar, we are getting a vector which is parallel to the original vector. See, if I multiply this vector by 2, I get a vector of magnitude 10. If I multiply by -2, I get again a magnitude of vector 10. Vector of magnitude 10, but it is in opposite direction. Now if I multiply this vector by 3, I will get a vector whose magnitude will be 15, okay, in same direction. If I multiply by -3, again a vector whose magnitude will be 15 but in opposite direction. So whenever you multiply a vector by a scalar, you are getting a vector which is parallel to the original vector. So k may vary, you can have different values of k, but for every value of k, you are getting a vector parallel to the given vector. And we have already discussed that parallel vectors are collinear vectors, right? In definition, in last session we have defined collinear vectors. So collinear vectors are vectors along same line, lying along same line or parallel. Means their line of action should be same. So whenever you are multiplying a vector by a scalar, you are getting a vector parallel to given vector, means you are getting a vector collinear with given vector. So set of all these vectors are collinear. So you have one theorem there, if two vectors, vector A and vector B, are collinear, then one can be expressed as scalar multiple of other. So that's why this scalar multiplication plays an important role in case of vectors problem. Why? Because whenever you multiply a vector by a scalar, you get a collinear vector. So if two vectors are collinear, one must be expressed as, one can be expressed as a scalar multiple of other. Or you can write it in reverse direction also. If one vector is a scalar multiple of other, it means two vectors are collinear vectors. Okay, so this is the scalar multiplication of two vectors. Now in algebra of vectors, we'll discuss what is addition of two vectors. Addition. Now you have seen that addition of two vectors in physics also you have discussed two laws. Right, one is triangle law and other is parallelogram law. So we'll first define these two laws and then we'll see when to use triangle law and when to use parallelogram law. So our next operation is addition of two vectors. So if vector A and vector B are two vectors, then their resultant, addition is also known as resultant. So their resultant is vector A plus vector B. This is addition of two vectors, or it is also known as resultant. So you always remember that resultant means addition. So if vector A and vector B are two vectors, vector A plus vector B is its resultant. And there are two laws to find the resultant. First is triangle law. Triangle law of vector addition. What it says, if vector A and vector B are two vectors lying along two sides of a triangle such that terminal point of first vector is the initial point of second vector, then their resultant lies along the third side of the triangle. Okay, so what do you see? Vector AB, if I represent this vector using initial and terminal point, vector AB plus vector BC, this is equal to vector AC. So in triangle law, terminal point of first vector is the initial point of second vector. See, B is common here. Terminal point of vector AB is B. Initial point of vector BC is also B. So whenever terminal point of first vector is the initial point of second vector, then the resultant, their sum, will be a vector whose initial point is initial point of first vector and whose terminal point is terminal point of second vector. So vector AB plus vector BC, this is equal to vector AC. So even if diagram is not known to us, what we have to do, you can just use a trick. The repeated letter should be eliminated. Suppose I have to add vector PQ with vector QR. Diagram or position of the vectors are not known to me. But here you can observe that terminal point of the first vector is the initial point of the second vector. So directly you can apply triangle law, and as a result ignore this repeated point, and as a result you can write their result as vector PR. Okay, so even if diagram is not given to us, we can apply the triangle law just by mere observation. PQ plus QR will be vector PR. So this is the triangle law. Now suppose vectors which we have to add are not in such position. That is, if terminal point of first vector is not the initial point of second vector, but the two vectors are co-initial, suppose. Now in last section we have discussed about what are co-initial vectors. Vectors having same initial point. So suppose vector A and vector B lies along two adjacent sides of a parallelogram, then now this we are talking about parallelogram law. What it says, if vector A and vector B lies along two adjacent sides of the parallelogram, then their resultant lies along the diagonal of the parallelogram having same initial point or co-initial with the two given vectors. So if I draw vector A parallel to, I draw a vector suppose parallel to vector A and vector B parallel to vector B, completing this parallelogram. Suppose C is the point of intersection. OC will be the diagonal of this parallelogram, and the resultant A plus B lies along the diagonal OC. This is parallelogram law of vector addition. If vector A and vector B are two vectors lying along adjacent sides of a parallelogram, then their resultant lies along the diagonal which is co-initial with these two vectors. Okay, so you can see the difference between these two. Here I can write vector OA plus vector OB is equal to vector OC. So you can see the difference between triangle law and parallelogram law. In triangle law, one of the point is common in between, that is terminal point of first vector is the initial point of second vector. But in case of parallelogram law, both the vectors have same initial point and resultant will also have same initial point. So these three are same in case of parallelogram law. So whenever you are adding two vectors having such that terminal point of first vector is the initial point of second vector, use parallelogram law. And whenever you are adding two co-initial vectors, whenever you are adding vectors whose terminal point of first vector is initial point of second, use triangle law. And whenever you are adding two co-initial vectors, you have to use parallelogram law. So see one example. Suppose a boy is moving from point A to point B. After that he changed its direction and he goes in north direction up to point C. And you have to calculate its displacement. Okay, so total displacement is vector AC. So here displacements are one after another. First he traveled from A to B and then he traveled from B to C. So one after another the action is done. So what we have used, AB plus BC is equal to vector AC. Triangle law is used. So whenever you have to add two vectors which are acting one after another, you have to use triangle law. Now what about parallelogram law? Suppose a river is there which is flowing with some velocity v1, and suppose a boat is going in a direction perpendicular to the flow of the river with velocity v2. So suppose this is the velocity v1, this is the velocity of flow of the river, and this is in this direction a boat is moving and itself it is having some velocity v2. Now here you can see these two are co-initial vectors and both the vectors are acting simultaneously. At a time both the vectors are acting. So in such a case, resultant vector will lie along the diagonal of the parallelogram law. So this is v1 plus v2. Vector v1 plus vector v2. So when simultaneously two vectors are acting, you can use parallelogram law. If one after another two vectors are acting, you can use triangle law. So this is triangle law and parallelogram law of vector addition. Now we'll see, after these two laws, we'll see what are properties of vector addition. In properties, first property says vector, if A and B are two vectors, vector A plus vector B, this is equal to vector B plus vector A. This is said to be commutative law. What commutative law says? That if you change the order of vectors, result will be the same. So vector A plus vector B is same as vector B plus vector A. So suppose this is vector A and this is vector B. Then you know that by triangle law, this will be vector A plus vector B. Now suppose vector B is given to me first and I have to add vector A to this. Okay. So what will be the result? You can use parallelogram law. This will be vector A plus vector B. So does it change? No, you are getting same vector having same magnitude and direction. So if order is changed, their sum will not change. This is said to be commutative law. Okay. So vector A plus vector B, this is equal to vector B plus vector A, commutative law. Second law is associative law. Vector A plus vector B plus vector C. This is equal to vector A plus B plus C. This law is said to be associative law. Now you can prove associative law also, means grouping does not matter. If I add, suppose this is vector A given to me, okay, and vector B, one more vector is there, vector B, and if I add them to first, I am adding vector A and vector B first. So by triangle law, this will be vector A plus vector B. Now suppose I have to add, this is vector C given to me. Suppose I have to add vector C to it. So as a result, see, now you can apply triangle law here. Vector A plus B plus vector C. So as a result, this will be vector A plus B plus C. This is vector A plus B plus C. Okay. Now we'll solve right hand side. Suppose vector B is given first. This is vector B. I will draw it one more time. Vector B. Okay. And vector C is given. This is vector C. So first we are adding B and C. Again you can use triangle law. So as a result I get this by triangle law, vector B plus vector C. Right. Now I will add vector A to this. This is vector A. So vector A plus vector B plus C. So as a result, by triangle law, this will be vector A plus B plus C. Okay, so are you getting different result? No, you are getting the same result. So even if A and B are added first and then C is added to it, or B and C are added first then you add A, result will not change. This law is said to be associative law. Okay, after that, third law. Third law is vector A third law is vector A plus 0 vector. This is equal to vector A. So if you are adding 0 vector to any vector, you will get the same vector. See, this is vector A given to you, and you know that 0 vector have magnitude 0 and its direction can be considered in any direction. So this is 0 vector added to it. So do you get any change in it? No, so the vector remains as it is. So vector A plus 0 vector, it is equal to vector A. So actually 0 vector is said to be additive identity. So in case of vector, 0 vector is additive identity. This is the third property. Okay. In next property, we'll see what if negative vector is added to a vector. So just now we have discussed before this what is negative of a vector, right? The first definition we have discussed in this session is negative of a vector. So it is having same magnitude but opposite direction. So if a vector is added to its negative vector, you will get a 0 vector. Now see, this is vector A. Suppose vector AB, vector A is represented along vector AB. Then minus AB will be BA. This will be minus AB. If this is vector, if AB is equal to vector A, then you know that BA, this is equal to minus vector A. Let us add these two. That is A vector. I am adding vector A plus minus vector A. Vector A is AB plus minus vector A is BA. By triangle law of vector addition, B is common. So you can write AB plus BA as AA. Now what you are observing here, initial point and terminal point of this vector is same. So this is 0 vector. So in last video we have defined what is 0 vector. 0 vector are those vector whose initial point coincides with terminal point. So here initial point is coinciding with the terminal point, means this is 0 vector. So when you add a vector to its negative vector, you will get a 0 vector. So this is the third property, fourth property. Okay. Now after this, after properties of vector addition, we'll see what is subtraction of two vectors. Okay. For addition, you have two different laws, triangle law and parallelogram law. But for subtraction, no separate law is there. but subtraction can be defined using a triangle law. Okay, see, subtraction. Subtracting one vector from the other is nothing but adding the negative vector. If vector A and vector B are two vectors, then vector A minus vector B is vector A plus minus of vector B. That is, I am adding negative vector to a vector. Okay, see, this is suppose OA, vector A, and this is vector B, suppose. Vector A, vector B. Now you know that by parallelogram law, resultant will be this vector A plus vector B. But now I need vector A minus vector B. So what I have to do? I have to add negative of vector B to vector A. Now negative of vector B will be a vector having same magnitude, but the direction will be exactly opposite. So suppose this is vector AC. Minus B lies along AC, suppose. So length of AB is equal to length of AC and direction is exactly opposite. So this can be represented by minus vector B. So this is vector A minus vector B. So by triangle law of vector addition, vector A plus minus vector B lies along OC. So this is vector A minus vector B. So subtracting one vector from the other is nothing but adding its negative vector. So this will represent vector A plus vector B and this will represent vector A minus vector B. Okay. So this is about subtraction of two vectors. Next point we are going to discuss is polygonal law. Now law of addition can be extended to more than two vectors also, and then it is said to be polygonal law. This is the law of addition extended to more than two vectors. So suppose A1, A2, A1, A2, A2, A3 and so on. Suppose AN minus 1, AN. These are n vectors. Then you can observe that every vector, in every vector, terminal point of first vector is the initial point of second vector. So you can add them. Adding, as a result, you will get AA1 plus A1 A2 plus A2 A3 plus and so on, AN minus 1 vector AN. This is equal to AAN. Okay, so these vectors lies along polygon. So initial point of first vector and terminal point of the last vector will be the initial point of the resultant vector and terminal point of the resultant vector. So here AA1, A1, A2, these represents a polygon. Suppose we apply this for 3 to 4 vectors. This is vector A, suppose. Okay, vector AB is equal to vector A, suppose. BC is equal to vector B. CD is equal to vector C, and DE is equal to vector D. Let us find its sum. A plus B plus C plus D. Okay, so I will draw a diagram for this. One by one we'll add them. Okay, this is vector AB. Then BC is added to it. A plus B. So we are adding vector AB to vector BC. See what I get by triangle law of vector addition. Vector A plus vector B will lie along vector AC. So this will be vector A plus vector B. So vector AB plus vector BC. This is nothing but vector AC. Now I will add CD to this plus vector CD. So here I am adding vector CD. Okay, so this is vector CD, or you can call it as vector C. So again, using triangle law, this is AC plus CD is vector AD. AC is A plus B, CD is C, so resultant will be A plus B plus C. Okay, so what I get, AC plus CD, this is equal to vector AD. Okay, now I will add vector DE to this, plus DE. So I get plus DE here. Again, this is DE vector, suppose, represented by vector D. Again, using triangle law, AD plus DE, resultant will be along third side of the triangle, that is AE. So this resultant is A plus B plus C plus D. So as a result, what I am getting? Vector AE. So this is said to be polygonal law. See, this B point is common, then C point is common here, D point is common here. As a result, I am getting vector A. So this is extended form of addition of vectors. So more than 2 vectors can be added, and it is said to be polygonal law. So we have done it for a 5 sides polygon. More than this, you can apply the same law for more than polygon having more than 5 sides also. So this is the polygonal law.